Ground improvements. Why we need ground improvements? What are the methods available for ground improvements? Vibro compaction, vacuum consolidation, preloading, Vibro replacement stone columns, grouting, improvement by admixtures, dynamic compaction of soil. All those will be discussed today. I am Prasad from Structural Guide. Please subscribe our YouTube channel. You may get the notification on new videos. Why we need ground improvements? Ground improvements are done especially for the shallow foundation when they are constructed in weak soil. Based on the classification of soil under the foundation, the type of improvement are selected. The type of loading will also be taken into account when finalizing the ground improvement techniques. We have to consider the loading and the condition of the ground. Based on those two, we decide the type of ground improvement required for that particular soil. And also we have to take into account the nature of the structure when we finalizing the ground improvement method. Method available for ground improvements. I have listed here the 7 methods that are mostly available in the industry. Vibro compaction, vacuum consolidations, preloading, Vibro replacement stone columns, grouting, improvement by admixtures, dynamic compaction of soil. We'll discuss about all these methods in detail. Vibro compaction. Compaction of the ground by vibration is called the vibro compaction. In this method, the loose ground is vibrated to change the configuration of the soil to get the dense form. Due to the high vibration, soil particles are rearranged to a configuration that reduces the void ratio and increases the density. This method is more suitable for sandy soil because now in a normal soil with these vibrations, rearrangement of the particle will be very difficult. That is, generally the cohesive soil is resist to rearrangements. Therefore, cohesionless soil is more suitable for applying this method. Vacuum consolidation. What is vacuum consolidation? Vacuum consolidation is used for soft soil. If you have a soft soil that cannot be compacted or consolidated with other methods, we can use this method. It is a process of applying vacuum pressure on the soil which protected from the surface from losing the pressure by sealing membrane. As you can see in this figure, there is a protection on the top of the soil layer. So there is a protection or the membrane. You call the membrane. Otherwise, the vacuum pressure will be loose. So you have the apply the pressure. Otherwise, if you apply the vacuum, then the air will come here and the vacuum pressure will be released. So you have to protect the soil top layer by membrane. Then you can put the drains and then apply the vacuum pressure. Perforated vertical drains are inserted into the soil to generate vacuum pressure on the soil. It's allowed to drain out the pore water. When you apply the negative pressure or the vacuum, then it absorb get the water into that drain and you can remove the drains from the soil. As a measure of speed up this process, or if we required high consolidation, surcharge pressure could be applied on the soil. In addition to the surcharge applied from the vacuum. So you can, as a usual manner, if you want to compact, you can apply the vacuum. In addition, if you want to speed up or if you need higher consolidation, you may add the surcharge. So now with the vacuum, you take the water out, and with the applied pressure, the pore water pressure release will be increased because you will apply the water pressure or you apply the surcharge. Now this is what happened in the consolidation also. In the consolidation, when we apply the pressure on the soil, the water will release from the clay soils or that cohesive from the cohesive soil to the outside. With that, with the forward release, the settlement occurs. So here also we apply the same concept. You apply the surcharge there, and we apply the vacuum pressure. Then with that you remove the water bit pass, then you get the required settlement. Preloading of soil. This is one of common method used in the constructions. If you have a large area uh, to be constructed and large area to be improved, this method can be used. And so even in small area, this method can be applied. Let's see what's the vacuum. What's the preloading? Sorry. Preloading or pre-compression is a process of applying load on the soil to remove the pore water pressure over time. It takes some time. The reduction of the pore water pressure causes the settlement of the soil, and it is an economical method when it is easy to find soil for this purpose. Now you need to find the soil because now you have to fill it. As you can see here in this figure, you have to fill the natural ground. So for this purpose we have to have a soil. So if you have a soil, you can use this soil for preloading. This is done prior to the construction, as it's required to keep for considerable time, depending on the design requirement to have a required settlement. So depending on the design requirement, the time will be different and the settlement will be different. Based on that, the time you keep this preloaded soil have to be determined. This process can be implemented for compressible soft soils. Soft soil to medium soil generally we can use. Soft soils such as saturated clay, silt, organic clay, peat. These kind of soils we can use this method. You apply the preloading, then let the soil that we rest the foundation to settle the required level. Then we can construct the foundation because now we have reached the settlement that caused by the foundation pressure. Therefore, the additional settlement will be smaller. So you apply the pressure and you get the settlement. Then you apply the your load. Now you can see here this figure. You apply additional pressure. Okay. Then you apply. Finally, once you constructed, you have this pressure. So now, now we are going to construct the structure after the certain settlement has occurred. The expected settlement could occur when you do the preloading. Thereafter, there could be a settlement, but it is not that fast. Now, as you can see here, this is bit rapid, but when it go to this way, the settlement is very small when compared to this one. So there will be a settlement. The secondary consolidation settlement may be there, but it's by small amount. But the majority of the settlement has gone with the freeze preloading. Vibro, re- Vibro replacement stone columns. Vibro replacement is a construction of dense compacted stone columns in the soil. This method is suitable for improving the soft soil, such as clay, silt, etc. With the introduction of stone columns, the bearing capacity of the soil will be improved considerably. It is an economical and environmental friendly method. However, the economy may be vary with the availability of the machinery to use for this purpose. Now, to construct stone columns, you should have machines and excavation and replacing the stones in the ground. So you have to have machines. If you have those machines and the materials, you can use this method. Stone columns will be placed on a regular spacing depending on the loading you apply, and also you may calculate the settlement and required bearing capacity. Based on that, you may decide the spacing and the diameter of the stone columns. Grouting. I think most of you have heard about the grouting. This is more commonly used method in the construction, not only building, in dam construction and in many other construction when you need to improve the ground. Grouting is more commonly used in construction of dams and buildings. Grouting is used to fill the cavities in the rock and to dense decrease the permeability of the dams. Now, in the dams, you generally construct dam in the very hard soil or rock. So, if you have a permeable soil or permeable rock under the dam, so in a large dams you excavate up to the rock. In a large dam, you can excavate up to the rock. Beyond that, you construct the dam. So even in the rocks, there could be cavities and cracks. All those will be there. So with that, if you apply very high water pressure, the water will be seeped through these cracks. Therefore, we have to seal those. Therefore, we drill the holes and do the grouting of the rock. So depending on the grout intake or the Lujan value, so you determine the Lujan value and to find out whether the cavities or the rock is taking the grout or not. Based on that, you will continue the grouting. What we have to keep in mind is we have to control the movement of the water through the dam body. Below the dam body. As a result of the grout filling, cohesion and the shear strength also increase. Cement-based grout mixtures are used commonly, and admixtures that harden the grout quickly could be added depending on the requirement of the project. When there is a weak ground with sufficient permeability for, for flow in the grout, now the soil should, if you are going to improve the soil should be able to take the grout. If the grout doesn't flow through the ground, then the purpose of grouting may be not there, because grout won't be flow through the soil, then the ground improvement won't happen the way we expected. Therefore, grout can be injected into the soil for improving the bearing capacity, but the soil that you are going to improve should be taken the ground, or should have the cohesion, or should have the uh, cavities, or the should have allowed to move the grout through the soil. There are many grouting methods. So some of the method we use in the grouting I have shown in these figures: penetration, intrusions, so cremation and the displacement. You can see here the displacement and jet grouting. These methods are used in the grouting. Ground improvement by admixtures. When it says admixtures, it is always not the chemical admixtures as most people think. Mainly, there are two types of admixtures, namely inert admixtures and chemical admixtures. Inert admixtures consist of inert material that do not react with the soil but improve the density, grain size and grain size distribution and shear strength and the bearing capacity, and they reduce the porosity and the permeability. Chemical admixtures are usually lime, cement, industrial waste, combination of industrial wastes, and other chemical available in the market. Those are the chemical admixtures. Industrial waste. Coal combustion products such as fly ash and bottom ash, ground granulars, blast furnace slags, cement, clink dust, lime, clink dust are used as the admixtures. So you can use the admixtures, you can add this admixture to the soil and we can improve the soil. Dynamic compaction of the soil. What is dynamic compaction of soil? Dynamic compaction involves dropping heavy weight on the soil in a regular sequence to increase the density of the soil. Used when there is a large area to be improved. Weight to be dropped is selected based on the degree of the compaction required. This method is more suitable for granular soils to mention the following list. Now, this is more suitable for granular soil as we mentioned as listed below. Non-organic, non-homogeneous fill, made grounds, that are areas of land that is made by the man, that is reclamation lands. Reclamation area with different characteristics. When underground, obstruction are present. Soil with large air voids, refuse dumps, poorly filled ground, etc. The method used for this improvement involve more advantages such as the compaction of larger area of the loose granular fill, reduce the volume of the landfill waste, increase the density and the bearing capacity of soil, and reduce the post-construction settlements. This is very good method. If you have very large area, you can apply this method. As you can see in this figure, the 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 regular spacing, you apply the load or you let the weight to fall into the ground like this. You lift it up and then put it, let it down or let it free fall into the ground. So with that regular spacing, you compact the soil. So there are spacings that are determined based on the design, and weight also based on the design, and that is based on the degree of compaction we expect. So with that, you can see here in this figure also, this area will be compacted. So similarly, you apply somewhere here. So based on the compaction you require, the soil will be compacted. This is more commonly, as we mentioned previously, do for the large areas when you need to compact. With that, we end the today discussion on ground improvements. Let's meet again for new video. Thank you very much for watching our videos.